I just want to quickly check that we all know what the Cartesian plane is. So the Cartesian plane looks a lot like this, and it has a vertical axis, which we call the y-axis, and we have a horizontal axis, which we call the x-axis. And this is a really important thing for this particular topic, analytical geometry, because it all takes place on this in the setting. Now, these are really just two number lines that are meeting each other at 90 degrees. Okay, so they're just two number lines. That's why they have the arrows. But they're filled with these things. Let's call this point A. What are these things? What are these dots on the Cartesian plane? Who would like to share with me what these dots are? Am I making a dot-to-dot pattern, or if I put one here and say I put one here? What are these dotty things that I'm adding to the picture? You can put your hand up if you're willing to give us some audio feedback, or put it in the chat if you feel like you think you know. Yes, my people, this is correct. These are coordinates, and often coordinates, we give them a letter name. So maybe I'd call that A, B, this C, this D. And what we do is a coordinate always has the x coordinate first and the y coordinate second. So if we look at our A here, if we go 1, 2, 3, 4, 5, 6 across, the x coordinate of A will be 6, and the y coordinate is how high you go up. So 1, 2, 3, 4, 5, 6. Look at that. So the point A is the point 6, 6. And if we talk about points, points can be all over the Cartesian plane, and we always use these coordinate pairs to identify points. However, points can fall into different quadrants. So what quadrant, well, there's 4 quadrants. What quadrant are the points A and B in? Pop that in the chat. Which quadrants do you think the points A and B are in? Yeah, so we call this quadrant 1. And then I can see students are aware of that. This one over here, without any points in it, is called coordinate 2. This is called coordinate it's quadrant 3, and this is called quadrant 4. Okay, now I want you to read off for me what are the coordinates for B, C, and D. B, C, and D. So pop them in the chat, or you can use the audio function if you like, but you're going to have to look at the scale and identify what are the coordinates for B, for C, and D. Who feels like they know? Let's have a look. So we got to 6. So B feels like it's in line with 10. And Owami has said 10, 3. I think I agree with you, Owami. Who's got C? Who would like to share with their beautiful voice what they think C is? And remember, there's no, it's just about sharing your thinking more than it is about being perfectly correct. 2, 3, 4. And then 1, 2, 3, 4. But we need to be careful because it's in a different quadrant. So it's going to be 4 minus 4. So watch out for C. It has a negative part because it's going down to get here. So this would be 4 minus 4. Oh, I see mine. What about, what is D going to be? What's D, these coordinates? So that's going to be okay, so the first thing you have to be able to do with analytical geometry is identify the points, knowing where they are on the Cartesian plane, and even being able to plot them. The second thing that you need to be able to do is calculate the distance between points. And so let us take the distance between 2 points. Which 2 points should we choose? Which are nice ones? Let's say that the distance between C and B. So we'll make this long distance here. Now, to find the distance between C and B, so we've chosen these two over here, a trick that we use is we use Pythagoras because this is a right angle. So if I look at the green bit and the blue bit that I'm drawing in here, these are sides of a right angle triangle. And so if we can work out what the green bit is and what the blue bit is, that can help us work out BC or CB, the distance. Can you tell me by inspection how long is the green line and how long is the blue line? And I'm looking at this triangle here. I want to see, can you tell me by just looking at it, how long is the green line, how long is the blue line? So let's count. 1, 2, 3, 6. So that would be 6 units. And then what would the blue one be? 7. Okay. So it seems from looking at the board, we know that we can see that this is 6 and that the x distance or that green side is 6 units in length and the blue distance or the vertical distance is 7 here. Now, we could manually count these every time, but it would take a long time. And if we were using Pythagoras now, all we would need to do is we would say that the distance CB is equal to 6 squared plus 7 squared. Actually, the distance squared would be equal to this. And in order to get the distance by itself, we would have to square root 6 squared plus 7 squared. And so the answer would be, let's have a look. What do we get? We get 36 plus 49, huh? 36 plus 49, which would be the square root of, what would that be? 80, 89, 95, the square root of 95. Okay, now, everyone, it would get very long and boring if we had to do this every time. So what we do is we develop a formula to help us do this more quickly. And so this is the way the formula works. Instead of having to manually count the length in green, all we do is we say, in order to find the green length, we take the x coordinate of the second one and we subtract it from the x coordinate of the first one. So we go 10 minus 6 squared plus, if you imagine here, what's the y coordinate? It's going to be 3 minus 4. And we square that. And then we get a square root. Now, is that exactly the same as the one we got above? Well, in this case, have I made a mistake? 10 is not 10 minus 6, it's 10 minus 4. And 3 minus 4, yeah. So then that makes this one 6 squared plus 7 squared, which gives us the same answer. Fantastic. So using this process, is it 85? Did I make a mistake there? 85. Oh, thank you, everyone. My apologies. Don't be afraid to use a calculator. Okay, so from this idea, we develop a formula which is just that we say this squared plus this squared, and inside of that, we have the distance between the x coordinates and the distance between the y coordinates. And that will give us the answer to this question. So I want you, using this new formula, to find me the distance between A and C. So A and C on the board, what is the distance between A and C? And we are using this newfound formula, which is basically Pythagoras inside of a nifty little formula. Okay, Isa has asked a very good question. How do you know which is x1 and which is x2? So it doesn't matter as long as you're consistent. What I normally do is the one that's further away from me, I make it like the second point. So in this case, I'll make A the second point and C the first point, but it doesn't matter as long as you're consistent. So if I choose 6 to be my second point, then I must also start with the 6 up here as the second point for y. And we can do example together. So we always know that we're going to have this part to start with. And now, if we're going from A to C, if I choose 6 to be my x2, I'm going to get 6 minus 4. But then I can't now start from the one down here now. I have to start with the one that I started with. So here, then I'd get 6 minus 4. And then if I take this, I get 2 squared. Now minus 4 is actually 10 squared. And so you should get the square root of 104, which in decimals would probably give you 10 point. It seems like it's going to give you 10.2 approximately. So this is something you have to be able to do very easily and very quickly. And so I want to practice this a few times tonight. So the distance between A and C would just be square root 104. And that's what we call surd form. And we normally leave it like that. Whereas this one, the distance was square root 85. We normally just say units because we don't know. So we just say units. And then here we would just say units. All right, now, one more like this before I can feel comfortable. I want you to find me the distance between A and D using the distance formula. Can you find me the distance between A and D? Manda, you can, when you say separate the root, what do you mean by that? I prefer to leave it in its surd form because it's most accurate. And so if in a later calculation you have to use it again, it doesn't, you mean you don't have to worry about all these messy decimals. So unless your teacher says for sure, write it as with 2 decimal places, normally leaving a distance as a surd is a much better way to do it. Okay. So I want to give you some time to work out the distance AD. Sometimes you see people write it like distance AD, or that is right, D. And then if there's any questions, now is a great time to ask. We know it's going to have this structure. Now, what's going to go inside? The exciting bit is inside those brackets. Pateko, if they say leave your answers with 2 decimal places at the end of the question, it's fine. But if you are using it in another question later on, it's normally better to leave it in surd form. Okay, so let's be consistent here. Now, which value would you like me to start with? Would you like me to start using the D first and then the A, or the A and then the D? Because I want to prove to you it doesn't matter where you start as long as you're consistent. So where should I start? I'll let the audience decide. Okay, start with the A. Okay. So if I start with the A, I'm going to start with the 6, and I go 6, and then I go minus 4. Now, because I started with the A, I also have to start with the A for the second one, and that's going to be 6 minus 4 as well. So what do we get below that? Well, 6 minus 4 is just 10. So we get 10 squared, and this is also 10 squared, which is going to be the square root of 200 units. And if it was left as a decimal, it looks like it's going to be about 14.1 units. Okay. Give me a thumbs up if you feel comfortable finding the distance between any 2 points, and give me a thumbs down if you feel unsure about how to do this. And be honest, it's fine. There's a big group, and so we're all at different places. Okay. Cool. So this is tool 1 for today that we need to get comfortable with, and we'll do some more practice towards the end. But for now, I feel like you guys have got it to a certain degree. With 1 or 2 kind of, we'll have some more practice at the end. But the second thing I want to talk about today is what is the midpoint formula? And the midpoint formula is actually quite straightforward. So if I give you, let me draw another Cartesian plane just like before. And let's say I give you a point over here. We'll call this point A, and we'll make it the point 2, 3. And I give you another point over here. And let's count this out. 3, 4, 5, 6, 7, 8, 9, 10. So 10 across. And then how many up? 1, 2, 3, 6, 7. Okay, now it's very easy to find the distance between A and B using the formula we just did. Okay, but we've done the distance formula. What I want to know is if I want to find the midpoint between A and B. So if we want to find the midpoint between A and B, how do we do that? And you guys are going to love this. So all we do to find the midpoint between A and B is take the first x coordinate and add the second x coordinate and divide it by 2. And that gives you the x coordinate of the midpoint. So the midpoint is going to be somewhere in the middle here. To find the y part of the midpoint, it's just going to be y1, let me write that, y1 plus y2 divided by 2. So if I'm going to ask you to find the midpoint M, and I want you to use this formula, can you work out what that midpoint is? Pop it in the chat, and you don't have to get it right the first time, but I just want to see if you can follow that formula. What is the midpoint? So I think x1 would just be 2 and x2 would be 10. So I get 10. And then for the y's, I go 3 plus 7 over 2. And so my midpoint should be 12 over 2, which is 6. And then 10 over 2, which is 5. And so this one over here is going to be, the midpoint is going to be 6, 5. How fantastically easy is that? Wow, that is awesome. So that is what we call the midpoint formula, and it allows us to find the midpoint between any 2 coordinates on the Cartesian plane, which is super useful when we get to triangles and quadrilaterals later on. But just to make sure you really know what's going on, let's choose two slightly harder points. So we'll make this 1, 2, 3, 4, 5, 6. So 6 across, 4 down. We'll make this D, and then we'll make this 1, 2, 3, 4, 5, 6, 7 across, and that's -7, 4. I want you to find me the midpoint between C and D. See if you can do that. So what is the midpoint between C and D? Give it a go. What do you think it is? I'm kind of guessing it's somewhere near quadrant 4, but that's just my visual intuition. My scale could be wrong. What we do here, we know we can start whatever side we like, as long as we're consistent. So -7 plus 6 over 2, and 4 plus -4 over 2. So what do we get for this? -7 plus 1, so that's that. And then 4 plus -4 is 0 over 2. So I get the coordinate -1/2, 0. So what that is telling me is that the midpoint is actually about here. It's on the, when the, oh wait, no, it's not -1/2, 0. Oh no, it should be higher. So my scale is a bit off here, sorry, because it's x is -1/2, so it should be about here. Oh, just check that we are right there. -7 plus 6 is fine. Yes. Okay. So visually, it's not saying that it's there. It's actually saying that the midpoint is about, they're saying that it's about there. When y is 0 and x is -1/2. Okay. It doesn't look perfectly like that, but that's how you would do it. Any questions or comments about the midpoint? So quick vote, thumbs up if you feel like you understand the midpoint, thumbs down if you feel unsure of the midpoint formula. So these are tools. So today is all about filling up your toolkit. And so far we have introduced you to 2 tools. Now, we're going to practice these tools in the second half of the lesson. And so those who are feeling unsure, I really encourage you to ask questions. But the main idea is we know how to use these 2 tools, and we understand what the Cartesian plane is very well by the end of today. Okay, we've been going for just over half an hour, and it's time to take a little break. So if I could have everyone on their feet, and if I could have you joining me in a little bit of communal silliness, because we can. And what I want you to do is I want you to start by swinging your arms like you're a swimmer at the beginning of Olympic Games. You know, when they get up there and they swing their arms, swing those arms, and just twist your body a little bit. Just let it rotate a little bit at first. And then as you get looser, you'll find your body goes even further. Okay, and shake it out a little bit, get nice and loose, and then just roll your shoulders backwards like this, and then roll your shoulders forwards. Okay, then take your shoulder and just stretch it out quickly, because your shoulders tend to get quite tense when we're looking down at the computer, and then switch to the other one. And feel a nice stretch into the muscle. Okay, let us do a high heart rate activity. So get your heart rate up, get the blood moving through your body. We did air skipping last time, but I'm going to go back to our classic jumping jacks because I think it does still give us that little bit more bite. And so we are going to do, let's do 20 jumping jacks. So a jumping jack is just to go 1 and like that. Okay, start 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, halfway, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, sit down. So take a moment to let your breath catch up and take a moment to have a sip of water if you've got some nearby. We are going to go to our little Maths 24 puzzle. And so for those who are new today, I know there are quite a few new students, what we try and do is we try and make, oh, my heart rate has definitely got up. So we try and make 24 using the 4 numbers on a card. At the moment, there are 2 on the screen. There's the red one and the blue one. And you have to use each number once, and you may only use the operations plus, minus, times, divide, and brackets. So see if you can make 24. It's a little fun game that we play just to keep our brains loose and in the mood for maths after we've had a tiring half an hour. Okay, Andile, let's have a look. Wow, that didn't take long, Andile. So the first card, 8 times 3 times 8 minus 7. This is 1, so it doesn't make much of a difference. And that is indeed 24. Well, Andile, you are on form today.
Nicely done, Andile.
Yeah, let me, since you ate that for breakfast so quickly, let me bring in the yellow challenge one that I promised you.
Yellow today.
Everyone's getting
spicing it up.
Everyone's getting good. We've got to keep expanding your brains. Who can make 24? We may not be able to do the yellow one today, but who has an idea for how to do the blue one? Masana, don't worry. Initially, you need some strategy. So what I look to do is, can I make it 8? Can I make a 3? Can I make a 6? Don't worry. And it's good mental exercise for you. Any ideas so far? Who has a... Blue is impossible. I got 23. Me too. I like it. It's fine. We can leave them here until we get them. So we can always come back to them on Wednesday. But I'll just give 30 more seconds before I move on. It's good to have a bit of a challenge. Andile, let's go to you. What's can we unmute Andile? I see his hand is up. Hey, have you got some?
Yes, first I'd like to minus the 2 from the 5.
Oh, okay, the yellow. So 5 minus 2, yes. Okay.
So then we times it by 3.
Okay, yep. 3 times what?
3 times 8, sir.
3 times 8, okay, which is good. And then what do we do then?
That's where I got stuck.
Aha, it's a good, you got to 24. The problem is you need to get rid of that 2 somehow. But I like it. I like it. Beverly, you say you got yellow. Give us a hint. And what I'll do is I'll leave these on so that we can try them again on Wednesday because they're good ones. So we have to use, okay, let's go to Beverly. Can we unmute Beverly there?
Hi, sir.
Hey, what have you got for me?
I'm actually excited for this one, but
I'm too. Is that
I got 8 plus 5
Okay.
which is 13, times
Ooh.
2, which is 26, minus 2.
Wow, very well done. That was
Nicely done, Beverly.
8 plus 5, then times by 2, which is 26, and then take away 2, and you get 24. Yo. Okay. I would love to stay here for longer, but we must move back to the other maths, but really well done, Beverly. And yeah, maths 24 can be really fun. And as you keep practicing, you get better. And yeah, even if you weren't good at it today, don't worry. That's part of the journey. Okay, let's go back and start doing some revision here of what we've done tonight. So first of all, tell me what are the Cartesian coordinates of the point A? Give me a answer for this multiple choice question. So it would be 4, and then it would be 2, which is correctly B. B is the correct answer. I think maybe that was a little, you guys had that in the box, in the bag. Let's try another one, but a bit harder one. Move this down. What are the Cartesian plane coordinates of C? So this one over here. So -2, -3, it is indeed A. Okay. If I gave you the point -2, 3, this is a bonus. I made this question up. What quadrant is that in? What quadrant is that in? The point -2, 3. So -2 would be going in this direction, and then 3 would be going up. And so this would be in the second quadrant. Okay, so remember, because you start, quadrant 1 is here, quadrant 2 is there, quadrant 3 is there, quadrant 4 is there. So -2, 3 would be in quadrant number 2. Okay. Cool. Let us do some more revision from today. I want to know what is, let's see if I can move this down. What is the distance between these 2 points? I want you to, what is the distance between -2,5 and 4 - 3? And is it option A, B, C, or D? So we know it would have this basic structure. What do we get for our answer for this one? Aha. I do believe the correct answer is A. Yes. There we go. I like it. I like it. Okay. So if you made a mistake there, don't worry, we're going to have some more chance to practice. But are there any questions before I move on to the next one? Just want to practice these skills. Manda, let's go to you. Can we unmute Manda?
Good evening, sir.
Hi, Manda. How's it going?
I'm good, thanks, and yourself.
Very good. What can I help you with on this question?
So I actually wanted to ask about distance formula itself.
Okay.
So can you say, can you write that square root of x of a minus x of b square plus the square root of, can you like separate the two
Okay.
roots into 1 and 1? That's what I actually wanted to ask.
Okay, so I'm not sure if exactly what you mean, but the thing is with the distance formula, you have to have this part is non-negotiable. So are you okay with that part?
Oh, okay, yes.
You must have that. If you don't have that, it's not the distance formula, it's another formula. Then
Okay.
you have to pick a 0.2 and a 0.1. I normally pick 0.2 as the one that's furthest to the right. And that's why I went 4 minus minus 2. So inside here, you have like a subtraction. What I normally do is I just say this one minus this one, like that. And then you go this one minus this one. So that's y2 minus y1. Okay.
Yes, sir.
Let's practice this idea on the next one. So let's try. This is a little bit sneaky, but not terribly sneaky. So it says -3, 2, and 12, 10 are points on opposite ends of a circle. What is the radius of the circle? See if you can work that out for me. I'll try and do a little drawing to help you, but where's -3, 2 is probably like here, and 12, 10 is probably like, it's like up here. And what they're saying is that there is a circle. Well, it's not too bad. And they want to know what the radius is, which is going to be either the yellow length or the green length. So does anybody have some tips? How would we go about doing this question? Can anyone help me? Like, what strategies would you use? I'm always interested in strategies more than numbers. What should I do first? I was thinking maybe I should just find the distance between the two. Like, yeah, Okonele agrees with me. So I get this part. And then what am I going to do? Well, I'm going to go 12 minus -3, so 12. And then I'm also going to go 10 minus 2. And then I have 15 squared plus 8 squared, which, if I use my calculator, is 289, but square rooted, so, which is 17. Now, the problem is 17 the correct answer? It's not. It's not, because this is the diameter and the question asks for the radius. Yes, Kabotso. So Kabotso, what do I do? What do I need to do to get the radius from the diameter? Yes, Federico, this was a custom. I threw it in there just to see how much closely we're listening. Andile, half of 17. Yes. So you take 17 divided by 2 to find the radius. So this would be 17 over 2, which should be 8.5 for C. C is the correct answer. Okay, so watch out. When we later on in the section, we're going to start dealing with circles. We deal with triangles, different types of triangles, different quadrilaterals. And it's helpful to know, this is basically the middle. Oh, ladies and gentlemen, I just had a brilliant idea. I want to know where the center of the circle is. So you've just told me how long the radius is, but I want you to use what you know to find me the center of the circle. And I'm not going to tell you more than that. I'm just going to say, if you use what we learned tonight, you can find me this big blue dot over here. What's it going to be? What's the center of the circle going to be? Manda, I think you're onto something. So Manda has thrown the word sonic, the same thing, the midpoint formula. So what is the center of the circle going to be? I do think the midpoint formula is helpful because you know that you have a radius here and a radius, so it must be halfway between. So can we remember how to find the midpoint formula? We go, well, -3 plus 12 is the x coordinate. And then I think it will be 2 plus 10 over 2. So what do we have? We have 9 over 2 and 6, or 4.5. And that looks right to me. It looks like that would be about 6. Sorry, no, that would be about 4.5. Yeah. So this should be about 4.5 across and about 6 high to get to that. Now that was getting a bit harder. Give me a thumbs up if you understood what I was doing to find the center of the circle there. Because that was getting harder. I'm really starting to mix things together now. Okay, now later in this topic, what I might do then next is say, can you find me the equation of the diameter? And can you find me the intercept and stuff like that? Loyola, what I said was finding the center of the circle. What I did was I took the 2 points at the edge of the circle and I found the midpoint. And where the midpoint is of that diameter is going to be the center of my circle. And so that point is going to be 9 over 2 and 6, or 4.5, 6. Did that help, Loyola? Otherwise, put another question in the chat and we can talk some more. Okay. Pleasure. Let's go on to another question like, let's go and do this. Move that one out the way. So I want you to find me the midpoint of AB. Which of the 4 options is going to be correct? To find the midpoint of AB, find where A is, find where B is. Pleasure, Lilo. So here's A and here's B. So we're looking for something over here, which is the midpoint. It cuts this in half. I think that should be the midpoint, which is going to be 2 over 2 and 9 over 2, which is 1 and 4.5. Am I going crazy? Let's have a look. So -5 plus 7 is 2, and then divide by 2. And then this is 2 plus, oh, this should be a minus. Look at where it is. So that seems like an error to me. So that should be -2 plus 7. which is going to give me 5/2, which then gives me, oh, is this an error? The reason because the reason I said y is negative, okay, you know what? This is a bit of a bad question, because if you look at this, oh, I made a mistake. Sorry, everyone. I have made a mistake. The y should not be negative. It should be, let me reverse a little bit. So -5 and 7, they're happy. And then I should say 2 plus 7, which is that, which makes this 9/2, which then gives me 1 and 4.5. Apologies, I didn't see the C down here. It is. Oh, everyone, I think it's been a long day. You have to excuse me. But because we are a team, we got there in the end. So well done to everyone. Okay. Let us feel like I've got to find something a little bit more hasty for you. Let's have a look. Let's maybe let's find some trickier numbers for you. Let me get this one. Then I'll come to that last one if there's time. Okay. Find me the midpoint between those two line segments. What do you think the answer is going to be for that? So -2 plus 3/2. And then this one is going to be 9 plus -2/2, which should give me 1/2 and 7/2, or 1/2 and 3.5. So it's also important to be able to change from improper fractions to mixed numbers in this section. And so we see that that would be C. All right, we're almost done for tonight, but I want to know what is the distance between these 2 points. So not the midpoint, what is the distance between these 2 points? Can you do that for me? And then I think we're going to call it a day for today. But you've done well. We've done a lot of practice. And I definitely feel like after this lesson, you have a solid foundation in the distance formula and the midpoint. In the next lesson, we're going to do straight lines and gradients. And then once you have those 2 tools solidly behind you, we can start looking at the sort of the higher level stuff. What is the distance for this between these 2 points? Oh. Okay, sometimes I skip when it's -11 squared, it gives you the same as 11 squared. So then we should have the square root of 25 plus 121. And if you're using this in further calculations, I highly recommend, Yazi, let's go to you. Can we unmute Yazi? Yazi, what was your question? Or were you going to give me the answer? Can you hear me, Ozzy? No problem. Okay, 146. And I would leave it as that, but if you put that into decimal form, you should get approximately 12,08. All right, everyone. That is it for tonight.